Hello everyone, my name is Lucy and on behalf of the organisers Oliver Kinross, I'd like to welcome you all to the Festival of Digital Construction USA. I'd like to give a big thank you to all of our sponsors, but with a special mention of Avvir, our sponsor of today's session. Today's session will kickstart with a short presentation followed by a panel discussion on reality capture and analysis, value today and possibilities of tomorrow, moderated by Raffi Holzer and joined by our fantastic lineup of panelists. There will be plenty of time for Q&A throughout the session, so do take the opportunity to submit your questions in the questions box on your screen. I hope you all enjoy the discussion. I'd now like to hand it over to you now, Raffi.
Hi, everybody. Nice to, meet everyone. I'm Raffi Holzer, CEO of Avvir, and I'm really excited to jump into our discussion today of reality capture, reality analysis, the value it can bring today and the possibilities that it affords for tomorrow. Before I do that, I'm going to just give hopefully a brief and somewhat informative and maybe even entertaining infomercial for Avvir. So let me share my screen with all of you. Great. Confirmation from the organizers that we're seeing what we're supposed to be seeing.
Do you want to just try resharing? It just looks like it's cut off part of your screen, Raffi.
I'm seeing that as well. So I'm going to stop and try again. It was working a second ago, but that is how these things go, right? There we go.
Yeah, that's coming through.
Okay. Fantastic. So a little bit about Avvir. What we are really trying to build at Avvir is what we refer to as a system of reality for buildings. Our word or our phrase for a true system of record. And the reason we call it a system of reality is because what is missing and why a true system of record doesn't exist in the construction or built environment space today is largely the lack of a connection to reality. So we have these, first of all, disparate data systems that we care about when it comes to construction and buildings. We have the schedule, we have the plans, we have our schedule of values, we have change orders and RFIs. Typically, they live in their own siloed software environments. But what's really preventing those systems from acting as a true system of record or a single source of truth for the various stakeholders on a construction project is that it's almost impossible to keep them up to date given the pace of change on a typical construction site. The only option you really have is manual entry. And if you tried to manually update each of those systems and on a daily basis, for example, you couldn't help but fall behind in a really dramatic way. So what we're doing at Avvir is taking the building information model, we're leveraging BIM, and frankly, the way that it was probably always intended to be used as a true database for construction, and we're marrying the building information model with reality capture data. So all of the unstructured data really that's coming from the field, today we're focused on photography and laser scans. We're analyzing that data and we're using it to automatically update that building information model. But typically, we're not just focused on the 3D aspect of the building information model, we're also integrating the schedule to create the 4D model and the costs to create the 5D model. So we have this really holistic view of a construction project through the BIM, and we're tying it to reality via the data that we're capturing in the field. And so the way that this works is typically a customer will upload their BIM to us. They often, though our partners can provide the service as well, will get scans of the job site either via, again, Lidar or 360 photography. Where we really step in is in the analysis phase. And so we make reference in the title to this panel around reality capture and analysis. That's a big focus of ours, is that capture of data from the field is not really going to do the job in and of itself. That data can't just sit there. It needs to be analyzed in order to be utilized. And then once we have analyzed it, we enable our stakeholders to then use it to fix a mistake in the field to catch up on a schedule on which the team is falling behind, or even to make updates to the building information model. So one view of this, the way you can think about this is we're taking two data sets. We're taking that federated BIM, right, typically also involving the schedule and the schedule values, marrying that with the reality capture data that we care about. And then out of that, you can get all of these interesting values, an automated 4D analysis of your progress, an automated 5D analysis, really just generating earned value analysis for the project in real granular detail, an error identification, or what we call a deviation analysis, right, comparing existing conditions against design intent, and then really using the above analyses to power things like resolution or reconciliation of invoices and pay apps, and insights into manpower allocation. So I spoke a little bit about, how we emphasize the reality analysis piece of what we do. I'd like to kind of set the table a little bit and just position where we are in what I call the reality capture workflow. So we're often thought of as a reality capture company, but I think the capture nomenclature is too broad a bucket for all of these companies to sit in. So I've kind of broken it up into three verticals. In the reality capture workflow, you've got the actual capturing of data, then you've got the contextualization of that data, then the analysis of that data. All of those three steps need to happen before that data can really be acted upon. So in the capture bucket, I think of mostly hardware companies. So you've got actual photography companies, Lidar companies, robotics companies, all enabling capture of that data. And certainly there is some bleed over. These buckets are not completely discrete from one another. There definitely is bleed over where companies, some of these hardware companies do it contextualization and a little bit of analysis. This is really where the primary value of each of these companies lays. The contextualization, what that means, just to give an example, when it comes to construction photography, if we look back 10 years ago, construction photography was somebody walking around with a digital camera and handing somebody else a USB key full of photos that were going to sit on their desktop. And when somebody looked at them, they had no idea what they were looking at. When were these from? What part of the building am I looking at? And now you've got companies that are offering real context. When I look at a photo, I see what photo is next to it, so I can really contextualize myself spatially in the building. And I also know what date I'm looking at. And then you've got the analysis of all of this data, right? So what we found is if contextualization is really helpful, but if you're getting 1,000 photos a day, or even just 1,000 photos a week, who actually has the time on a busy construction project to examine those and make use of them in a proactive way to actually power decisions based on the data that's incoming? And what we found is that typically the answer is nobody. So we at Avvir, in addition to some other companies that we're competitive with, wanted to take that data and automate the analysis of it. The ways in which I think we're unique in this space, and this is where I'll do my sales pitch, is we're one of the only companies, I believe, that can ingest both LiDAR and photography. So we're a multimodal data company. We're also, I believe, the only company in that space that is truly hardware agnostic, so we can work with any hardware out there. And I believe we're the only company in the space that is really closing the loop between the field and the plans. And what I mean by that is we actually enable our customers, for example, if they identify an issue, a discrepancy between plan and what's happening on the site, to actually, for example, update the BIM with the click of a button to reflect the as-built conditions. And the reason that that's important is if we're comparing against a set of plans and those plans are not regularly updated, then the comparisons that you're making, if the plans are getting increasingly out of date, then the analysis that you're making becomes increasingly useless over time. So really closing that loop and making sure that the plans you're comparing against are the plans that are being worked off of and are relevant is incredibly important to making a product like ours relevant for everybody on site. And I see we've got a little slide conversion issue here, but the one thing I want to touch on this slide is really just where we focus today. You know, we've got a broad vision that I'll touch on in a second, but we're focused today on 4 critical workflows. One is updating as-builts to reflect, you know, updating building information models or other plans to reflect as-built conditions, both during and after, or sometimes before construction begins. Error identification and rework prevention, progress tracking and schedule updating, and then finally payment reconciliation. So we're trying to enable the automation of these 4 critical workflows and ultimately create a platform where the data that we're providing is useful for any other workflows that people might be interested in as well. And the other way I think of Avvir is really as the glue connecting the field to existing tools. So this is, you know, speaks to the platform play that we're making here. We don't think we're going to be able to do everything. I don't think any company really can. What we do want to make sure is that no matter what tools you're using in the office or in the field, that the data that is being entered into them is accurate and relevant and timely. And so our goal is really to connect, you know, whether it's Texture or BIM 360 or Procore or anything else you're using, to ensure that the data that's being input, first of all, potentially doesn't need to be manually input anymore. And second of all, that it is accurate and timely, and that the decisions you're making can be based off of data that makes sense and is relevant. So just a brief kind of snapshot look at what the product actually looks like. We've got our construction verification, what we call our inspect module. And you can see here basically a bunch of elements in red, which are indicative of elements that are out of tolerance from where they're supposed to be. And then our project or progress tracking dashboard, where you can see on a per trade basis, actual progress being tracked against scheduled progress and projections being made based on past productivity. And I mentioned, you know, I would speak briefly to the long-term vision here. The goal is to become not just the system of record for construction, but really for the entire building lifecycle. And we're interested in particularly in enabling payments. It's one of our key value propositions that we're chasing, to really make payments in construction a much easier process than it is today, and a much less frictionful process than it currently is. And then also to extend the concept of connecting reality to our system as a record to the operation and maintenance of buildings as well, right? So to extend throughout the rest of the construction life, or the building life cycle, not just its construction phase. And that is it. I'm going to transition to our panel, which I'm really excited to get into. And feel free to reach out if you are curious about Avvir. This is my email. And really, you can reach out to us through our website or any other way you're interested in. Thanks so much. All righty. So I think our panelists can share their cameras now as well. And I'm just going to introduce everybody briefly. All righty. So joining me today on this panel are Shaun Lewis, currently the BIM VDC Digital Practice and Technology Manager at AECOM. I'll read the formal bios as well. With a diverse background of AEC experience, including civil engineering, surveying, and construction, Shaun brings practical approaches to technical workflows. He's developed reality capture programs at 2 of the larger GC firms in the area. in the DC metro area, and is currently the BIM VDC Digital Practice and Technology Manager at AECOM. He oversees a group of passionate technology professionals revolutionizing the way assets are captured, documented, and delivered. Tim Conroy joined DPR as a BIM engineer in 2011 after graduating from Penn State College of Engineering. After 4 years in the BIM group, he joined the National Innovation Group, where he would focus on middleware development, AR/VR, the Internet of Things, UAVs, and other cutting-edge technologies. While in the innovation group, he started the UAS core group and UAS user group. After 3 years with the innovation group, Tim joined the operations team for a large data center project, where he would lead the reality capture group and subsequently the larger VDC group. Since the beginning of 2020, he's been leading a newly formed group at DPR that focuses on implementing technology to improve the work being performed in the field. All right, Brian Ringley is a construction technologist at Boston Dynamics, where he promotes new value-add autonomous capabilities for construction project delivery and works to expand the construction application ecosystem with the Spot SDK. Prior to Boston Dynamics, he was a senior construction automation researcher at WeWork, where he managed the construction robotics research program and contributed to initiatives in design automation, unitized prefabrication, and construction site progress monitoring. He's also taught architecture courses for many years, most recently at Pratt, where he led seminars in computational fabrication and industrial robotic automation for industrialized construction. Eric Law is at Swinnerton currently. He's pushing technology to the limit to elegantly solve construction business problems. Eric is a recovering entrepreneur leading the innovation team at Swinnerton. Previously, he led the construction product team for Bentley Systems after the acquisition of his company. Eric Law earned his BS in mechanical engineering from Cal Poly San Luis Obispo. To escape technology, he heads to the mountains with his families to ski, mountain bike, and climb a rock or two. Eric, I did not know that. We should catch up. And Brooke has distinguished herself at Skanska as an innovation powerhouse. She's developed her skill sets at the Jacobs Institute for Design and Innovation while studying civil engineering at the University of California, Berkeley. At Skanska, she utilizes design thinking principles to guide innovative development, following the process of empathize, define, ideate, prototype, and test. Brooke implements this method every day as emerging technology project manager at Skanska USA. She's responsible for driving innovation and new technology adoption on all projects in Oregon. Brooke also facilitates national tech pilot programs and enterprise rollouts, providing her insights to key innovative strategy development. Brooke is deeply knowledgeable in the full range of construction technology solutions and is constantly searching for the highest impact tools. Alrighty. So I'm going to, I think that covered everybody, yes? Fantastic. I wanted to start this panel off just with a definition of what reality capture is. So I mentioned during the infomercial for Avvir that we focus on photography and laser scanning, and I think those are the primary modes of reality capture that people think of when they think of this space. But to me, reality capture is really broader than that. It's whatever means you have of capturing any sort of reality in the field. So that might be wearable devices that are capturing where people are at any given point in time. It might be the security cameras on site. Certainly includes drones and any other sort of sensor that is telling us something about the nature of the reality of the construction site. So with that definition, I want to roll into, seeing the poll results, very cool. I want to roll into this discussion. I mean, reality capture definitely seems to be having a moment right now. A recent report that I read estimated that the size of the Lidar market is growing 20% year over year, and adoption of drones on construction sites is increasing by 2 to 3x, 200 to 300% every year. I want to pose to the panel, what do you think this rapid rate of adoption of, of reality capture technologies in general can be attributed to? Essentially, why is this happening now? And Brooke, I'm going to ask you to kick us off.
Yeah, for sure. I think there's a few different major factors here. One of the biggest ones is really just folks understanding those use cases even more fully than before. I think a lot of times with technology, we're excited about the tech, but we don't always think about what the application is. So there's a much better understanding of how we can actually get value out of these tools. I think also when we think about technology, a lot of times it's really expensive. So as we have some of this technology driving down in cost, specifically with drones, it's so much more affordable for project teams to get a drone, maybe for their whole region, maybe even for a specific project. Just the wealth of resources that are available and the low cost for these materials make it a lot easier for people to dive in with these technologies. And then lastly, we're seeing so much more access within mobile tools. iPad and iPhone Lidar is now enabling people that are on the job site to use these tools. You know, folks that maybe never would engage with Lidar scanning are able to actually see what these applications are and come up with all of these new ideas for how they can use this technology to impact their projects.
Cool. Anybody else have any thoughts on this? I'm curious also, you know, there have definitely been technological changes, I think, that have made it easier to adopt some of these tools. But I'm also curious to hear about some of the institutional changes. You know, have we gotten better at all, or maybe not, at fostering innovation? I know, Shaun, you've helped actually create some of these reality capture organizations. Was wondering your thoughts on that.
Yeah, absolutely. I'm going to point to three things that I think that really has changed the culture and fostered innovation in construction. And number one, first off, every single person on this panel, if you look at the titles down below, has technology or innovation in it. Those type of positions did not exist 5 or 10 years ago. So what does that tell you? That tells you that the higher ups, the businesses realize that there's true value in doing these things. And that's why we are all here today, because we provide that value to the companies. The second thing that I see that has fostered that the new culture of innovation is colleges. Colleges are now teaching BIM where they didn't before. So you're going to have construction managers coming out of school that have at least a general understanding of models and why they're being used in the construction industry. And then lastly, the third thing is nothing's going to make a GC do something more than if they're contractually obligated to do so. We're seeing now being written in the contracts, you have to use BIM, you have to do this or that, and then the GCs, that gets passed on to the subs. Well, the subs also have to provide models. And so with that, that's how you get paid. So that's going to push it, I think, more than anything else, is if you're contractually obligated to have those technology innovations. So that's why I think it's been driving it.
So I definitely am of a single mind with you on that. I see, you know, GCs tend to be reactive organizations as a rule, though there are definitely exceptions. And it's interesting to see owners now putting that into their RFPs and demanding that, you know, BIM is part of the package and reality capture is part of the package. Eric, I'm curious, you know, how do you think that happened? Because I don't know if owners are they just reacting to new tech or to people, you know, coming out of college? Like, where did this germinate?
No, so it's not a reaction to new tech. It's a reaction to, we can answer more questions with the tech, right? Everybody's looking at data for cost. Everybody's looking at it for schedule. What's the current state? What's the future state? And now today we can get that data from data essentially, right? Traditionally it was Excel spreadsheets and web forms filled out in the field with graphs and quantities of work put in, or you looked at your pictures and you filled out a spreadsheet, right? But now today I can take photos or a LiDAR scan and I can go straight to progressing my schedule, right? I can go straight to quantity of work installed. And that's a huge change, right? And all of our clients, you know, we've got some big clients that are really pushing us for cash flow. You know, they're managing both multi-billion-dollar programs across their portfolio. And so cash flow is very critical for them. And so they want to know how much work goes into place on a monthly basis or a weekly basis for some of them. And so we can capture much more accurate and much more granular detail with the pictures and the LiDAR and convert that into those reports for them. Much more consistent than we can with people, right? The challenge with people is every foreman, every superintendent, you know, on Friday afternoon, they're trying to get done with the job site. They're trying to punch in their quantities into a sheet and get off the job. And there's going to be human bias in that quantity, right? It's not always consistent Friday to Friday, right? Some days they spend a couple hours on it. Some days it's 5 minutes because they're running behind because there was an issue on the site. And so by being able to take pictures in LiDAR, we can get consistent data off of all of our job sites. And I think that's a big change, right? So we've got the model now on the design side, so we can compare the pictures and the LiDAR to it. And then we can answer those questions for clients, architects, and ourselves as well. You know, labor productivity is very important to contractors.
Yeah. I mean, two of the things that I'm thinking about now, and I'm curious, and I'll just pose them to the panel generally. One is, do we think that there is there a particular profile owner, for example, who is the kind of owner who's saying, I need this technology on board as part of any proposal you submit? And second, are there general contractors who are now becoming more proactive in they're not waiting for the owners to request it, they're actually diving in headfirst, and why? And Tim, actually, maybe you have something to share on that.
Yeah. So hopefully you guys can hear me okay with the mask, but
yep.
Yeah. So I think the one thing that, and I don't want to make this all about DPR, but the one thing that I think sets us apart from a lot of GCs, and I would say similar to the other GCs on this panel, is we don't wait for the owner to ask us to do something. And to the slow adoption, it was kind of a slow burn to start. It's that flywheel just trying to get momentum. The equipment was really expensive not too long ago, but as the price came down and as we had more and more success stories, we added fuel to that flywheel, and it started spinning. More people got to see it with the cloud. We could share this data much more broadly. So then, it only takes one or two success stories to be like, man, there's something in this, and it's like asking for more, asking for more, asking for more, and it just gets going faster and faster. At DPR, we don't wait for the client. We love it when the client asks for it. We've also seen it where maybe they go one step too far, where they're asking for more, and we have to say, oh, time out a second. Let's manage expectations here, because the worst thing we can do to the flywheel is it's going faster and faster, and then we have this massive, whoops, we misstepped here, and then now maybe it comes off the axis and or the axle, and it's rolling away. So waiting for the client is not our style. It is really encouraging to see the clients asking for more and more of this, because the trades are seeing value, we are seeing value, the owner's seeing value, all the stakeholders, like I said, with the advent of the cloud and getting the data out there, because let's be honest, this data is generally very heavy, very dense, and so getting more eyes on it, getting more success stories, yeah, we're definitely moving in that direction.
Got it. And I know in terms of bringing the cost down, I know how Lidar has definitely dropped in price dramatically over the last number of years. Brian, I know Boston Dynamics definitely has a point of view on costs coming down, particularly with respect to labor. But I'm wondering how you see the cost of reality capture having come down, and also how robotics plays into that. Have we turned a corner, or is there a corner an inflection point we're about to hit where it just becomes omnipresent?
Yeah, I mean, I think that there's always been a desire to bring automation into construction environments. And I think we recognize that there have been a number of parallel advancements in addition to the work we've done on dynamic robots capable of entering those environments, such as the costs of reality capture coming down, as well as the right software and kind of data management systems surrounding those technologies. One of the things that I often say to people who criticize the construction industry for being behind in productivity or being behind technologically is I say, actually, there's an extremely mature eco-technology ecosystem out there that we're really benefiting from. Customers have strong priors in 3D information management and reality capture. We're able to then identify a gap, which is the desire to both kind of increase the frequency of data capture while decreasing or eliminating the amount of resources required to do so. And that's what we're really excited about. So it's certainly collaborative between multiple advancements in technology.
Does Boston Dynamics, you guys have something that's walking around on site? Is that, there's something out there?
Oh yeah, I forgot to mention, we make robots and they can walk through your construction site.
Yeah, and by the way, Brooke, I'm just reminded when I was reading your bio and talking about, design thinking and that approach, and I know there are probably a number of you who are, will want to chime in on this. Is there a wrong way, I guess, to especially as a contractor, to think about bringing on new technology? Because one of the things I think, Tim, you were talking about, sometimes owners, and I guess this could happen to anybody, will get ahead of themselves. I want all the newest, flashiest stuff. Not necessarily thinking about what problem am I solving with this new flashy stuff. And I'm curious, if you guys have stories that you might be able to share about how you've addressed that kind of grab the tech as quick as you can impulse, the dangers of that, and how you kind of solve for institutionally at your own companies.
Yeah, I think a lot of us have changed the dialogue with tech of really seeking out that problem first. It's hard not to just chase the cool new technology, but I think, you know, enough of us has learned that most of the time, if you chase the tech without having a problem in mind, you're not going to be successful. With design thinking, the very first step in that process is empathize. And it's really trying to understand who are your end users or the different players, and how can you understand what their problem is, but also sometimes understanding what the problem is that they don't even realize is a problem. It's really trying to understand what they're going through, what those processes are. And I think that that's being part of, you know, the framework for solving these problems more and more, maybe not in the specific design thinking steps 1 through 5, but people are realizing they need to understand what's going on the job site. I think that's really critical to actually having these things stick and be successful. I think with the new technology and kind of those requests from the owner, I love when owners are going to ask for something specific, but you know, the first question is why? Why do you want that? Why do we need that? You know, is this actually going to impact the project, or do you just want to say that we're doing it? So the more that we can ask why, and ask why to the people that are actually going to be impacted, the more success we're going to have with new technology.
Fantastic.
Yeah, Raffi, real quick to add on to that, I think, you know, it's more prevalent today, and it'll be more prevalent tomorrow, and you know, every day thereafter. More and more technology is coming out. Technology is not slowing, and if we aren't very tactical about how we apply, and like Brooke mentioned, you know, starting with why, what's the problem statement? If we don't focus on that, we will introduce, you know, even more technology fatigue for our field, for our office, for the owner, the client, the subs. Everyone will feel that. If you look at how many pieces of software you touch in any given day, you know, I could probably say I'm 30, 40, 50 plus things that I'm touching in a day. And so if you don't have that clear problem statement and you just start chasing that shiny object, it'll fail because you don't have discipline and you're not focused on what you're trying to solve, or you may not even know what the definition of success is to judge whether or not you've got there or not. So being very tactical and starting with why is a big factor in applying new technology.
Thank you. I mean, that is actually a perfect segue to the question I wanted to ask next, which is why? So I think we've kind of been discussing why now, but I want to discuss why at all, right? Why is reality capture important? What problems are we actually trying to solve with it today? And I'd love to get into particulars, especially with those of you who are coming from GCs. I'll start with you, Eric. What problems is Swinnerton looking to solve for with reality capture?
Yes, I mean, it's a broad spectrum of problems, right? The traditional problem was documenting work put in place, right? We took pictures or we took videos or 360 cameras of just documenting it and sharing it with other project participants, clients, and architects and say, hey, this is what it is. And then today, kind of on the bleeding edge, we're looking to take that reality capture and turn it into the numerical values, right? The cost and the schedule and the progress of the job site, and answer those questions with those data sets. And that's a pretty big spectrum, right? It's probably about 10 years difference between, our bleeding edge innovation projects and standard practices on job sites that we do everywhere. And there's a lot more opportunities as well, right? And there's some computer vision that's looking at safety. There's computer vision that's looking at quality. There's different tools that are looking at it. And so for us as a GC, we look at it as opportunities to improve our processes and to leverage the investment in the model. We've spent a lot of time and money on our VD&C teams, and now we can leverage that investment for multiple workflows, right? So how do we actually put that model into the field and then validate it, right? So we've got this model, we've got this design, now we can compare it to the as-built conditions in a 100% digital workflow. Right, I don't have to have somebody log in and say, hey, is this column in the right place in the model, and is it in the right place in the picture or the Lidar scan? I can overlay them, right? And so I can get quality control really quickly. And we can do quality, forming slabs, right? Or all the embeds in there, is all the bar in the right place, right? There's a lot of opportunities coming forward with it. And that all leads to reducing cost and schedule, right? If we do the work the first time and we do it correctly, or we catch any issues before we pour the concrete, that's a big cost saver, right? And so it's really helping out. And then we're moving towards actually putting the model to work in the field. We're testing some robotic solutions where they're actually putting work in place in the field, right? So the model goes and feeds the machine that actually does the work, and you get a true digital twin, right? That's kind of panacea is to get the digital twin. Well, if the model, you're building 100% off of the model, there's no need to check. It matches, right?
Yeah. No, and that gets to, I guess, an add-on to this question, which is how do we think about, ROI, the return on investment for our investments in reality capture technology, and how do we make it as useful as possible, but also demonstrate that we're driving real value and utility. And I'm wondering, Shaun, you've done this a lot at a couple of different construction companies now. How do you drive that home? How do you prove your worth? Any stories that you can share?
Yeah, I'll just say something, a simple one. A very simple example is floor leveling. So this is a interior renovation project, and so it's an existing slab. And the sub that was going to do the floor leveling, let's say he quoted for $100,000 and said there was going to be 80,000 cubic feet of leveler, whatever it may be. So we went out and we scanned the whole thing, provided floor leveling analysis, and then gave them actually the cubic yards of what it was going to take to do it. And it was lower than what they were trying to charge us. So what ended up happening is that was just a job saving right there. And that's just one simple example of an interior renovation. Other ones are, I'm going to talk to some existing conditions ones because that is kind of the low hanging fruit. Say if you have historic buildings and you're building around these historic buildings or attaching to these historic buildings, if someone took a drawing and made a plan and just measured this corner of the building and this corner of the building, what elevation did they measure that at? They probably measured somewhere near the bottom where they could just hold their tape up to. So if you go and laser scan it, now you know this point, this point, this point, all those different data points. And if you go to attach something onto it, it's going to fit versus having to field cut something. Anytime you have to field change things, it ends up with cost and delays. This is a project we worked on. This was years ago, 655 New York Avenue. There was 13 historic buildings, one that got picked up and moved, and then a new building was being built in between historic buildings and then over top of a historic building. We scanned that a lot. I can't even tell you how many times we've scanned it, and it just proved invaluable mainly on knowing where those historic buildings were because they all fluctuated. They all had ins and outs, and they were tying to those and building around them. And that right there just gives all the value. Another job, interior renovation with low ceilings, where they had to tie MEP inside of the ceiling. It was a waffle grid, and to document where waffle grid is traditionally, I mean, it's the labor amount of that is astronomical, but you can go in and scan it in a couple days. Now you know that entire waffle grid, so where you can put hangers in and put in the piping. That job specifically that we did paid for the scanner itself.
Got it. I'll share my own anecdote. This didn't happen to me. This is a story that I heard, but it's one of my favorites. I don't know what building it was, but apparently there was a building being built in Manhattan, and it was supposed to be a 50-story tower, and the slabs were supposed to be 8-inch slabs. That's what was called for on the plans. The slabs that were poured were 10-inch slabs, and nobody noticed until they were about to top out. And if you accrete those 2 inches on every floor, they basically, when the inspector came, realized they had exceeded their height restriction at 49 stories. So they ended up with a 49-story building instead of a 50-story building, which is just mind-blowing because that's where the profit margin was for that entire building, was probably on that last floor. And it's just crazy because it's a small, 2 inches is a small thing and nobody ever noticed, which may also kind of segue to the discussion I wanted to have with you guys around reality analysis, right? So we've got a lot of people I know we saw from the poll who are taking photos on their site. And I know traditionally that's been for documentation where it's used in case of, a lawsuit happens, somebody will then dig through those photos. But from the conversations I've had, people are typically not going through those photos on a proactive basis, how important is it actually to have some kind of automated solution or any kind of solution, even if it's just a workflow, to actually examine the data that's being captured? And Tim, I'll start that with you.
Yeah, so I would say the feedback loop is ultimately what we're trying to shorten. I think you mentioned in your intro that, there is a lot of cost in delayed decisions, and I will stand behind the fact that my feeling is nothing is more expensive than delaying that decision. Even making the wrong decision is less expensive. Making the wrong decision and then fixing it later is cheaper than not making a decision. And so that indecision can be very, very expensive, both in time and money. And then rework ruins quality. So the thing that we're trying to solve is just can we take those photos? Can we take these scans? We spend so much time in the model to coordinate it, to design it, to get everything to fit, to try to look at constructability and sequencing. There's so many hours that goes into that model. And before reality capture, quick story, when I first started with DPR, I was a VDC engineer, spent all this time coordinating a 200,000 square foot medical office building that went into a 1970s office building. So no overhead space at all, and a waffle slab. I wish I had laser scanning. But I'm walking with the owner's rep, and they're like, so you spend all this time, i.e. we spend all this money to, how do we ensure that everything that you're coordinating is getting installed correctly? And me being new to the company, new to the industry, I'm like, well, so I spend a lot of time in the model, and so you start to pick up on things, and I can orient myself to the building, and I look up in the ceiling, and things just, you can spot things. I'm like, man, that was a really crappy answer. But they took it, they accepted that, and so now we don't have to take that. We don't have to make that guess. We have the pictures. We can analyze them. Like you said, we can be proactive. Now, we can only be so proactive because taking a picture of something that exists, if it's incorrectly installed, it already exists. So we can only be so proactive. We can be proactive on the fix, but it's not necessarily prevention. And so that's one of the things we're trying to figure out is how do we scan more frequently to catch the problem before it manifests? Can we start to see a deviation while it's still in tolerance, but it's getting closer and closer to being out of tolerance? Can we catch it before it goes out of tolerance? And so getting those photos and those data points analyzed rapidly by a computer, preferably, so that we can spend our human capital on resolving issues, not finding them.
Which also, is a nice segue to kind of what I hope, or I think what we collectively may hope, is the future of reality capture and analysis, which is something I want to get to, but I do want to, get to the disclaimer portion of our talk as well. I think there's a fair bit of excitement about what reality capture can bring. We already discussed how there can be pitfalls in terms of the adoption, right? If you reach at every piece of technology too quickly, and that isn't really baked into the organization, that can lead to poor results. But I'm also, curious to get from you guys, what are the things you need to make sure you're doing right? What are the potential pitfalls and challenges with rolling out reality capture, and how do you ensure that you get best results? And Tim, I'll actually start off with you again, but I want to definitely hear from
me.
Yes.
Yeah. So one of the things, and this is, I'll try not to go.
Go ahead, get on your soapbox, Tim.
I was say I don't want to stand too high on my soapbox, but this is very, very near and dear to me right now, because doing building control, doing the site control, bringing it into the secondary control, setting your building corners, bringing that control into the building onto the grid lines. That is, if it's not done right, you compound error every time you come off of a previous loop. And so if you do your property boundary and there's a little bit of error, and then you do your traverse and then there's a little more error, and you bring those into the building corners and it's a little more error, and then into the building, even more error. And all those, you may do a resection, using your like a P30 or something, and it may show that it's pretty good. But you got to remember that it's the error of that setup plus every setup before you as you go up the tiers of control. And so managing those expectations is absolutely critical. when we're talking about laser scanning and photogrammetry and everything in this industry. Everything has a tolerance, control, surveying. Nothing is an exact science. And so if you don't keep that in mind, you could scan something and overcommit on what that scan is actually showing. Because even let's say your control is perfect, it's not going to be, but let's just say it is. As soon as you do one setup with your scanner, you scan one 360, everything, you can look at the manufacturer's information. It may be accurate to a couple millimeters at 50 meters, and that's fantastic. But then you do a second setup that's 20 feet away, 30 feet away. Now you got to remember that you're compounding your error again. And so the more setups you do, if you're not tying back into that control, that roadmap, you could get off course and not realize it. Scanners today are a lot better than they were in the past with dual axis compensation. You don't have that runway that we used to have where you slowly drift and drift and drift. Next thing you know, your floor is vertical. So it's definitely getting better, but managing those expectations and managing that control network that allows you to localize and get your scan. If it's an existing condition scan, you may have to align it to columns. Just know those columns probably aren't perfect. And so if you don't go through and survey, you could get yourself into some hot water.
I've experienced that drift, by the way. It can create some very Inception-esque scenescapes. But anybody else with kind of points on which to be careful or potential pitfalls to avoid when deploying reality capture?
I think something that Tim mentioned a couple times is manage expectations. And I think everyone has that job title in their name somewhere, is an expectation manager. And that's probably one of the biggest things, is because let's say an example that I had years ago, that same job I talked about before, 655 New York Avenue with the 13 historic buildings. So I was scanning that whole site, and this was early on with a PM that was did not know laser scanning very well. So we went out, laser scanned the site, and we were there for, I think it was 2.5 days, scanning the entire site. And then he came back on, you charged 24 hours to my job. What were you guys doing? You just set up your scanner and it just does its thing and you're done, right? And then you have to explain to them a little bit more about it. And that's just like a simple about the laser scanning in general, but managing expectations is really big. Let's say 360 cameras, right? At first, everyone was staying static, taking a 360 photo, moving to another location, taking one, and the photos were nice and crisp. Now, that took too much time. So everyone's either attaching them to a hard hat or holding it and walking around. Pictures are a little blurry. And so that's something you just make sure everyone is aware of up front. Manage those expectations because it's just a pain. It really is. Tim hit on accuracies. If things are off and they thought they would be perfect, they thought you just go out and the whirly do thing goes. So it's always a challenge is managing those expectations.
Yeah, I think another challenge is that we're capturing our whole site and we're really laying ourselves out there. If there's anything wrong in those captures, if there's a safety issue, if there's a quality issue, if there's a mess, then we need to be mindful of that. I think one thing that we've seen on our sites doing more capture, our superintendents or our project engineers are going out there taking photos, and partly that helps with the awareness for our subcontractors so they know, hey, we're documenting this. So we've seen some behavior changes of people are aware of that. They're more likely to make sure, they have their gloves on and their glasses and they're cleaning up their areas. But also we need to be aware that sometimes we're going to capture things that don't necessarily show us in the best light. So what do we do when we capture that? Are we going to follow up on that? Are we just going to hide those scans? That's a challenge, I think, is, we're capturing everything. Sometimes it's not always the best things that we want to see. And then what do we do when that happens?
Yeah, and there's actually it's actually a nice segue to a question from the audience, which I might as well pull in now because it is super germane. So one question we have here is technology, especially drones and video, make it easy to see progress and add value. But how do we balance the risk of the same technology being used against us to show safety issues or other risks that could otherwise be hidden from view? And I will just give my one anecdote to this. When I first started Avvir, our very first pilot project, I won't name the company, but we were on a condo development, and we scanned the foundation, and we compared it against the building information model. And it turns out the foundation was somewhat off square, we'll call it a rhombus. And that could have had real issues, not structurally or anything, but just in terms of being able to install the windows correctly, right? You could have had a curtain wall issue with the foundation going up like that. And we thought that made our day, or made our month. Our first pilot to have such like an impactful find after our first scan was incredible. And then when we showed the results to the PM and the supers on that job, instead of congratulating us, they asked us to stop working on the project because they didn't want documentation of any errors they had made when they knew that they could work, or they hoped at least that they could work around it. And so, yeah, it was eye-opening for me, being a relative newbie to the construction industry at that point. But I am curious what your collective thoughts are on that question, how you balance the risk and liability with the value add that comes from reality capture.
That's tough. I feel it's hard when someone says, how do we balance the risk that someone's using against us? If they're on your job and they're doing something, their intent is to benefit the job. They're not there to come after you. They're there to help the job as a whole. And it eats at me a little bit. Being someone that's gone to a lot of different jobs, also as a sub-consultant, I come in, we're there to help. So don't think of it as it's someone that's coming in there that's going to identify something wrong for you. If something's wrong and gets forgot about, that's when a bigger issue happens, right? Like you can think of that Florida bridge, that there was issues that were there and they just pushed them aside, and then that bridge collapsed. So I look at it as you find issues, even if they're identified by someone else, you take care of it right away, because it can lead to much worse things later. That just eats at me a little bit to hear that.
Yeah, to me, solving the problem early is when it's going to be the cheapest to solve. Risk is a big challenge. If you scan something, if you fly a drone and take a picture of someone doing something unsafe, you've got to follow up. There are tools out there that help you identify that stuff, but nothing's worse than realizing you had the data and didn't realize there was a problem and then try to solve it later. The other thing that I think is a slippery slope is sometimes we feel like if we find the problem, don't tell the owner, don't tell the subs. Let's try to solve it ourselves. We'll get through it. We'll figure it out. To me, there's a little bit of that, but there's also sometimes you just gotta put your pride aside and say, you know what, guys, we found this problem. We're letting you know. We're not saying that we're not solving it. We're just letting you know that we found it. We're working on it. Know that we're working on it, but we want to be transparent about finding it in case someone else has experienced it before, because we haven't experienced everything. And one of my fondest memories of a job not too far from where I'm sitting right now, the owner's rep, I'm VDC guy going through trying to find all the clashes, trying to figure out all the potential, skeletons in the closet before anything gets built. And anytime we would run into something, I would call her up and I would say, hey, I just wanted to let you know we saw this, we're working on it. We think we can figure this out, but I wanted to bring it to your attention now so you hear it from me, and not whenever if the problem does grow into something much larger. I'd rather you hear about it early. And she said that was one of the greatest things about that job was she always knew that she could count on us to let them know that, hey, we've got this, we're still working to solve it, but we did come across something.
Eric, you had wanted to say something?
Yeah, continuing off of what Tim said, that problem's only going to get exponentially bigger later, whether it's a safety or a quality or whatever, and that's a cultural problem with companies. It's an industry problem. A lot of the firms have tried to change that culture of construction to say, hey, we've got to learn early, we got to learn often, and we got to do the right thing, because it's going to come back, right? It's going to come back. That firm that did the dimensions wrong, when they put the curtain wall on, they're going to have issues. They're going to truncaulk it. They're going to get leaks, and it's going to become a way bigger problem down the road. And so, that's where technology, it's not doing anything wrong. It's just exposing underlying issues that a firm's got. And that's what we're looking for, right? We're looking for tools to help us do our job better and deliver better projects to our clients, right?
Yeah,
that's why you got to be careful with your partners.
Yeah, as a non-GC stakeholder in this industry, I would echo the comments that I heard just now. It reminds me, frankly, of I used to be in medical technology, and there was a debate among hospitals about, because we live in a litigious society, frankly, here in the United States. And when it came to doctors, hospitals used to ask doctors not to apologize if they made a mistake, whether it was in surgery or in some other form of their practice, because apologizing was admitting guilt, and that could be used against you in a court of law potentially. What they found out, a number of economists found out when they actually studied this, though, was that if you didn't apologize and then it came out that you screwed up, you were gonna get sued. Whereas if you were apologetic and transparent about what had happened, you explained that you tried your best and you were gonna do whatever you could to fix it, but it also just extended some kind of empathy and aligned yourself with the patient or the patient's family, whomever it might be, you never got sued. It was almost unheard of. And so I think the often oppositional relationship that is somehow culturally present here between GCs and owners is unfortunate. I do hope it changes, because I think a lot of that could be avoided. But I do want to take the discussion to, I think, what might be the most fun part of this, at least from my perspective, which is what do we see coming down the pike? So, I guess the question I want to ask is, how do you think some of the challenges that we've talked about might be solved for in the near future? And what technology is coming down the pike that you're excited about, or what workflows or opportunities do you think they unlock? And what is the ideal state of reality capture and integration of technology into construction look like 5 or 10 years from now? Or what is the ideal state, and how long does it take to get there? And Brian, I know that was a number of questions, but really all about the future of reality capture and construction. And I'd like to start with you and get your take on that.
Yeah, I mean, I think what we're seeing right now that's really exciting is we're getting to that fundamental thing, which is I'm leveraging a combination of technology to be able to ask the question, what is happening on my site right now? That seems like a simple thing, but that's been something historically that just hasn't really been feasible. So I think while everybody's excited about the individual technologies, a spot robot walking on your site, laser scanning, the ability to analyze that, at the end of the day, they're looking for a business solution that lets them know what's happening on site. So the key to that has been this kind of fundamental shift from scanning as a kind of singular survey action that happens, once, maybe twice for due diligence or as-built, to the idea of continuous reality capture in a way that can be leveraged to give you near real-time insight as to what's happening, which is the key to a lot of the discussion that's happened so far about, it's good to know something early on, the sooner you fix it, the better, but you have to know it, and just capturing the data doesn't let you know something. So that's where I think we really need to get next. That is absolutely, I think, where Avvir is a key player, but more broadly, what I hope to see is that AI becomes meaningful in construction through the provision of easy to use computer vision models and scan feature recognition models that allow you to take this level of continuous reality capture and make sense out of it. Because otherwise what you end up doing is you end up moving the bottleneck, which is to say, oh great, now I can automate scanning with robots and collect as much data as I could ever dream of. But then anyone who has been in a traditional BIM platform or system or workflow knows that there's quite a bit of labor that goes into making sense out of that data. So for me, what I'm really excited about is we are clearly on the edge of having this. And you see it, right now you see it kind of siloed with individual vision models encapsulated in different project management software applications, whether it's an application for safety detection with like PPE or social distancing, or an application for like work in place detection for, say, a particular trade, like how much drywall has been put up on your project. What I'm hoping to see is kind of a more open CV marketplace where that stuff becomes a little bit more interoperable with the various systems, because it just simply won't be sustainable to subscribe to like 17 different software applications to get all of that vision automation you need for work in place quantification, for safety, for scan to BIM comparison. But I think we're close, and I think there are a lot of players both inside and outside of the construction market that will bring that to bear over time, and that will really be what closes that loop.
Just to tag on quickly.
Yeah.
So not that long ago, I had a client say, well, "Why don't you scan everything?" And they're like, "You can. Why? Just go and scan. Why? Don't sit down. Just go scan. Just keep scanning. Scan. And I'm like, "We don't want to do that." And they're like, "Well, why not? The scanning has gotten, shown us so many different things." I said, "Yeah, but every hour of scanning, it's maybe a half hour of registration, but then maybe 3 hours of review. And so if we're scanning too much, like Brian said, we're moving that bottleneck. Now we've got so much more data to analyze. And it's kind of funny. Big data was this big topic not that long ago in our industry. And I'm like, guys, we're not at big data. We're not there yet. In the reality capture space, we're getting there now with with Spot, with SkyDuo, with these autonomous capture platforms. And then, with the ability, to me, as soon as we can see, object recognition, recognizing a fiduciary marker that it auto registers to control, hats off, whoever does that first. But then that brings the data into Avvir or into platforms like that can automate the analysis. Maybe one day we have deep learning where, it's actually making recommendations on how to solve things. But until we get there, maybe that's a little further out, we still need that human interpretation. And so focusing on that piece of it, we may get to big data. And now we've got enough tools and processes in place to actually leverage that data.
Got it. Eric, sorry, excuse me. I'm curious to hear your kind of, what's like your ideal vision for what, reality capture brings to construction at some point in the future?
It's going to be an interesting mix, right? Because right now we still, you start to get into prefabrication, right? And as we prefab buildings, we bring out larger components, which are actually easier to quality check and control versus lots of small materials, hand cut on job site, stuff like that, right? And so we're kind of in an interesting race today, right? We've got the prefabrication initiatives moving forward where, we can prefab massive modules that we drop into place and bolt them together and walk off a job. And they're running. Right. And then we've got the reality capture initiative where if I were to do reality capture on prefab, I'd do it in the factory to make sure my modules are all, pre-built correctly with all the right components for a quality control step. And then I do it in the field to make sure they're all connected correctly. Right. So it actually reduces your reality capture substantially. And then we still got the traditional job sites, right? How do we go into existing buildings where we capture existing conditions? We put a new design in there, we go build it out, and then we check to make sure we did it correctly. Because it's it's a very fractured, diverse industry, what we have to do. So I see the opportunity for both, right? I mean, reality capture is going to grow. The cost has come down, right? I mean, the iPads and iPhones are now coming out with Lidar on a chip in them, right? I mean, the cost to capture is coming down, and the real big advancements are going to come on the processing side. Right? How can I get that registration to be done real time? How can I get that post-processing activity that was, a day or two to be done in minutes with the cloud? Stuff like that. So the superintendent can go out there with their iPad, scan it, and get an instant report that says, yep, everything's correct, or no, you forgot something. Right? I mean, just think about like the inspectors today, right? What they do, and they miss mostly, right? Most inspectors aren't checking every nut, bolt, every electrical receptacle, right? They miss stuff. But you can do that, right, with the power of an iPad in your hand. And so I think it's really impressive what we can do and what's on the horizon. We're still, early days on that processing side, right? I mean, we've been doing work with you guys and other firms to validate that and get those answers. But just in the last couple of years, it's come a long ways, and it's going to come a lot farther. I use the analogy if SpaceX can land a rocket on a floating barge in the middle of the Pacific Ocean, well, frick, we should be able to do anything in construction, right?
It's a building that builds itself.
Yeah, exactly.
So I want to move to audience questions, actually, as we're coming up on time soon. But Shaun or Brooke, anything to add about kind of your vision of the future of reality capture in construction?
I want to manage some expectations with the iPad or iPhone Lidar. So you're not going to go out and scan a whole site with an iPhone or an iPad. But as Eric,
it doesn't work.
You're just not going to do it. But as Eric mentioned too, I think that he hit on something with an inspection. Inspection might just be on something right here, on a singular kind of feature or something right in front of you. that could definitely work. Future-wise, I think the biggest innovative thing that could really help is 5G. Once 5G really gets rolled out and you're able to transfer some of this data faster, that's going to inhibit all those other tools that we're talking about. It's going to make it work. When you're out in the field, you don't have Wi-Fi. A lot of the times, a job doesn't have Wi-Fi set up for X amount of time. If you're able to get data pushed around easier, it's going to speed up everything and get to what Eric even mentioned about real time. So I think 5G, I think
Eric, we're working on it. Give us a second. And Brooke?
Yeah, I'm really interested in what those insights are going to be from the data analytics. After we have all that data, let's say we have laser scan data from every single day. What is that telling us, and how can we change behaviors or change plans with that information? I think specifically, some insights for if there's any schedule delay or if there's any issues that need to be fixed, what's the optimized plan to achieve, equilibrium in your schedule? What do you need to focus on? How many crews do you need from each sub in order to get to that spot? So that we're spending less time, having to work through those problems and really having a computer optimization tell us this is the best plan of attack moving forward. I think I'm also interested in how we can incorporate some wearables and IoT systems into some of the reality capture or some of those data insights. With the laser scanning, we can see what the project looks like, what's going on, but it's not as dynamic as some of those wearables of where people are, where equipment is, how things are moving across the site. And so pulling in both of those data streams in order to find out some of those insights, and maybe it's giving you optimized location for your break areas or your material laydown, and it's really just getting to that optimized construction site. I thought it was really interesting what Eric brought up as well as moving towards automation and construction and ultimately an industrialized construction site. In some ways, I feel like the laser scanning BIM capture is almost like a separate optimization of how we're doing construction now, whereas the automation and construction is moving towards piece by piece building these Lego blocks. So maybe competing objectives for how we're actually carrying out our construction processes. But really at the end of the day, I think those data analytics are going to tell us a lot in order to make those best decisions as soon as possible for managing our projects.
Fantastic. So we have, I think, about 5 or 6 questions from the audience, all of which seem really interesting. I think about 15 or 20 minutes to get through them. So just bear that in mind while we're responding to them. So Shaun, you actually were talking about inspections just a second ago. And our first question is, a GC or CM doesn't have full control of the risk associated with AHJ inspections, especially around their busy schedule and holidays. Can tech tools be encouraged for them to use so they can do remote walkthroughs in a faster, safer method? I want to turn this over to the panel, but I actually have something to say on this question. We actually, Avvir just raised a round of funding, which we're very happy about. And our primary backer in that fundraise was really interested in the ability for municipal inspections to be done via technology, to be done certainly remotely. And they actually have a lobbying team working on making this happen. So this is something Avvir is actively exploring with some of our partners. And so, yeah, I hope to God stuff can be encouraged. But I'm wondering if if you guys have a point of view on this. What can be done vis-a-vis AHJ inspections?
I think virtual inspections can be done all day. I think there's 2 aspects of it. One, we've kind of hinted at with reality capture, or 360 cameras, or even some of the other higher resolution cameras that give you that virtual walkthrough environment. Those are great, but they're kind of after the fact. What I've seen at previous firm is they were experimenting with things like Google Glass, or even with cameras just attached to either hard hat or glasses, and then they could walk with the inspector. So the PM or the super was walking on the job, and then the inspector was seeing everything he was seeing, and they were just talking through it, and that's how they were able to get some of the things inspected. That was at really the peak of the pandemic, where it was more out of necessity than creating a whole new way of doing things. But I personally, I think without question, you can do remote inspections And again, points about 5G. You know, if you're able to walk and have something like that with a streaming video doing an inspection, I don't see why that wouldn't work really well.
Yeah, we actually, because of the pandemic, we actually switched how we did these things. And so you can use AR to kind of see things as you go. You can use the HoloLens. The one thing we learned with that kind of remote stream is if you've got two people watching the same feed, sometimes, you know, if the way our eyes work is as we move our eyes, you don't see anything. You actually, your brain blocks out that signal because otherwise you'd see a blur. Well, someone else watching a screen of you moving, they're going to see that blur, and they're not controlling where your head's going or what you're looking at, and we can be very jarring sometimes. And so doing that live inspection can be very nauseating. And so we've started to look at, well, if you want to see something, is it accurately built dimensionally? You scan it. If you want to see what the finishes look like, maybe you go in with a Matterport that does a little bit of scanning, but it's more on the photo side. And so you can get that architectural feel of the space. Then if there's any problems, you go out with a camera or a HoloLens or something that you can have that one-on-one live interaction, testing door swings. Does it have the right hardware on the lock set? You know, okay, I saw this one thing, I couldn't really see it clearly. Can you walk me out there to it? And so again, applying the right technology for what that end goal is. Do you need to have a lot of people do the review? Then maybe you want to do it in like a Matterport or a construction site or something that allows that more on your own time, making comments, adding little tags. And if once you whittle down the number of issues that are remaining, then maybe you go one-on-one with that inspector with like a HoloLens or something. And so we've actually changed how we do our inspections now.
Cool.
Yeah,
I think there's a lot to be said for building an autonomy and giving someone the independence to choose like where they stop and what do they look at and what's that view. So when you do like a Matterport or even just a 360 video, letting someone pause, look around, actually have more control. I think that that's something that you lose when you do a live inspection through HoloLens or AR on a phone. People are really dependent on just where that person is going.
And Brian?
Yeah, sorry for interrupting everyone 1,000 times. Yeah, this is something we just saw become a popular application of the robot during COVID. So we had really focused on the idea of repeatable and autonomous data capture. But then there was the obvious need also to just use the robot as telepresence, to be able to remotely access a site and walk a site as needed, to use human intelligence sometimes to navigate a site and observe something. But what that also brings up, as was just mentioned with 5G, is the barrier of connected job sites or the lack thereof. So I think we've seen some really promising exercises with the robot with LTE, and we expect that to really take off as job sites bring on 5G. But as anyone who's worked off of job site temporary Wi-Fi and things of that nature knows, that that really has to be developed in parallel to some of these other technologies if you really want to be able to drive robots or stream video or things of that nature that have larger bandwidth requirements.
Got it. So I will just say as a last point on this topic, if anybody, Avvir is ultimately interested in automating a lot of these inspections. So if anybody on this panel or in the audience is interested in discussing that, so not even just remote, but just automating those municipal inspections completely, get my email after this conversation. I'd love to talk to you. Third question we had from the audience, near and dear to my heart, this topic, when pitching a technology tool to a client, do you pitch a value proposition only, or do you also calculate ROI? How do you capture that ROI, considering tech often provides preventative measures, which is an intangible? I deal with this problem all the time. If we are doing rework prevention, it's like selling insurance. Unless you think you need insurance, how do I quantify that to you? So, Eric, any thoughts on this?
I think the important part, Raffi, is we don't pitch tools, right, to our clients, right? To our clients and our project teams, we pitch services and solutions. Very rarely do we actually pitch a specific tool that says, hey, here's a tool from XYZ vendor. We pitch it as a service that says, hey, we're going to do XYZ on your project. Here's why we're going to do it. Here's a cost, right? If it's an insurance cost, here's an upfront cost. and then here's the reduction. It's very similar to what we did with modeling and BIM, 15 years ago, where we said, hey, we're going to model and clash this design up front, and it's going to result in reduced change orders down the road, right? Because we're going to take care of all the coordination up front. And so whenever we pitch to a client, it's always a service. And it's always based on how we're going to build your building, better, faster, higher quality, safer, cheaper, whatever it may be, into it. And then the other thing too is a lot of the services that we consume, the clients don't see, right? As a contractor, we own delivery of that project. And so it's usually a lot of times it's internally pitching it to a project team that says, hey, we want you guys to use this new solution or this tool set on a project because it's going to improve quality. And we're very upfront with those teams that says, hey, it's a new solution. We want to prove this out on your job. Here's the risk to it and stuff like that, the cost, all that good stuff. And here's what we're looking to prove, right? Because before we scale anything out and we expose it to clients, we want to prove it ourselves. We want to make sure it does what it's supposed to do. Because a lot of times our solutions are encompassing, 1 to 6 technology providers, right? And you got to make sure it all works together. Very rarely is there one provider that comes to us today that says, hey, I'm going to solve your problem and answer all your questions. Right?
We're working on that too.
Perfect. Right. I've got hardware, I've got software, I've got processors, I've got data management, right? And so we always look at it as a complete solution if we take it to our clients.
Yeah,
I think with
those vendors, jack of all trades, master of none.
Yeah, that's a good point. And Brooke.
Yeah, I think with the ROI calculation, a lot of times it's really challenging to do an ROI calc on some of these tools. What I found oftentimes happens is we have like one story or one case study where using that tool paid for the entire service or our tire license. And I'm sure others can relate of you have that one time that you really need it, and then you can't imagine not having it. And so trying to communicate those stories, I think also a lot of times I'm more likely to pitch a tool internally to project teams, to executive leaders of why it makes sense to use this. And that's where telling the story, really focusing on the use case and why that added value instead of a number calculation for ROI, it's going to be a lot more effective communication tool.
Brooke, I'm going to pick your brain after this conversation. I do want to, we have a number of questions to get to, so I want to move on to the next one here. The next question we got from the audience is, emerging technologies are very useful. However, one critical factor that is often overlooked is how to integrate this in the existing ecosystem. In other words, process, databases, etc. How can GCs alleviate a siloed approach, sub-optimizing small part of a long value chain that needs to be integrated holistically? I'm not sure I understood the last part of the question, but I think we get the gist.
Yeah, I think Brooke hit the nail on the head earlier in the conversation that if you start with why and you look at the process as a whole, these things, what often happens in our industry, at least from my experience, people see a new tool. And Raffi, I'm going to throw you guys under the bus here a little bit, just as an example, but people may say, I want to use Avvir because they offer something that I want. But if they don't think how do we fit them into that process first, you may find yourself spinning your wheels trying to figure out how to adopt this tool and not knowing why. And so if you start with that why and you look at the process, you define, choosing by advantages, you list out what you want it to do, what you need it to do, and then you look at the technology to find out who does that best. That helps to alleviate. You're not forcing a new technology into a gap. You're opening a gap for that technology to fall into.
Yeah, and I will say, to prop us back up, one of the things our product team takes very seriously is really how do we fit into not just existing processes, because sometimes from my perspective, certain processes do need to change, but also how do we fit into this ecosystem, right? To Eric's point, we're not, there is no point solution that does everything, right? So how do you build a system, a solution that's going to work together with other systems or systems that are already being used to make an integrated solution rather than just a product?
Yeah, and I just wanted to clarify, I used you guys as an example.
I know.
Just because you're convenient.
I think another piece of that is communication to the end users. A lot of times we'll throw new tools out on projects and people don't really know why we're doing that. And so being really clear to communicate, why are we using this tool, and spell it out super clearly, especially if there's other tools that are similar. I like to just have a list of like, these are all the tools that do similar things. these are the feature analysis of these things. So if people don't understand maybe why we use one or the other or when to use that, just really clear communication to the people on the job sites of why we're making some of those changes.
Yeah. So we've got a question here about, is there such a thing as too much reality capture? But I think Tim actually, as that question was being asked and sent to me, Tim was speaking to that that very question. So I'm going to skip that one and just go to the next. Is SLAM tech good enough now? For those who don't know, SLAM stands for simultaneous localization and mapping. Is that tech good enough now to be used with software like Avvir? Okay, that's an easy one. Yes, it is. So there, SLAM in this context, I think, is referring to the mobile laser scanners that are out there. And it's a yes, but, right? So there are really trade-offs between the mobile scanners and the terrestrial scanners out there. There's a built-in accuracy trade-off. But even more than that, it's actually, to one of the points Tim was making earlier, it's much easier to line up some of those terrestrial scanners with an existing survey control grid than it is for some of the mobile scanners that are out there. And then there's also the in-between solution, which is putting a terrestrial scanner on something like the Boston Dynamics Spot. So you now have a mobile terrestrial scanner. But yes, for certain, we recommend SLAM scanners actually for certain use cases where the accuracy is not as vital. It's a much less expensive, both in terms of capital expenditure and operation, a much less expensive tool than the terrestrial scanners overall. So you've got to know your tools and you've got to pick the right one for the job. That's generally my philosophy. Anything to add there, anybody?
Yeah, we literally just scanned a floor. You might be familiar with it, Raffi. This is up in New York job we're working together on. We did it with a mobile scanner, BLK to go, and we also did it terrestrial. The terrestrial always is going to give you high accuracy, but we're tying into control, so there's always a margin of error. As you heard Tim when he got in his soapbox, I guess that way. He got in his soapbox about control. So that's with the terrestrial side. So let's say that's maybe a half inch, let's say. With the BLK2O, things we've found is there's certain ways to go about it. You can't just grab one of these mobile scanners and just walk around and expect everything to be really good. But we did notice in small areas, you do small areas, tie those together. But we saw even one of those small areas of 2 inches of drift with the mobile scanner. So that's something. Will it work with a lot of things? Absolutely. But you got to know what you're getting at. If you're going to try to say this is installed 2 inches off, but your scanner's 2 inches off, that doesn't really fly. So
yeah, I'm not going to throw any scanners under the bus today in this forum or promote any of them. But if anyone's interested, we've done a fair bit of analysis and research on which ones are better than others, and happy to answer those questions offline. I think we've got 2 more questions, and we've got maybe 1 more minute. The presenters can let me know. But this might be our last that we can take. Question 7, do you think photogrammetry algorithms will develop accuracy comparable to Lidar scanners? And do you think terrestrial scanners are on their way to obsolescence, being unseated by drones and wearable scanner tech? I think we just kind of answered that second piece of this, but what do we think about photogrammetry developing accuracy comparable to Lidar?
I think it's possible.
I'd say possible, but not probable anytime soon. Taking a flat static image and calculating depth, I don't personally see it. Not yet. I mean, we have done some comparisons of like the point cloud generated from a drone through photogrammetry, comparing it back down, tying it to ground control with RTK, checking a head wall, and it was remarkably accurate. But will it get to the point where it's rendering the terrestrial scanners unnecessary? My gut says not likely, at least not for a little while yet.
Brian, I'm curious your thoughts here, because as I understand it, the main limitation here, frankly, is SLAM algorithms and just knowledge of a camera's position, orientation, et cetera, is always going to be somewhat limited. And that would be the main limitation to understanding the position and orientation of one image versus another and being able to recreate a 3D model from that.
Yeah, There, there are long-term trajectories where we could start to see some of these things converge, but for the time being, they're really vastly different technologies, and they're good for different things. It always comes back to defining what are you trying to do. If you need to validate MEP being sub-centimeter accurately placed, that's a terrestrial scanner. If you're looking to do general progress quantification over time, and you don't need that level of detail, then you can start to decide whether some of those other technologies might have different pros and cons for those other applications. The great thing about Spot in particular is that that's a general mobility platform for any of these sensors and any of these use cases. And that said too, we're also working with partners like with Trimble to say you can have different mission parameters. You can have that scanning mission parameter where each of those scans are putting out millions and millions of points, because that's what your use case is and that's what it requires. But you can also easily adjust that on the fly to say that I want a really quick scan there as well. So even within any of those technologies like photogrammetry from 360 video, continuously registering SLAM-based laser scanning, or traditional kind of waypoint by waypoint terrestrial scanning, all three of those also have a spectrum of performance and parameters within them. So I think it's good to understand the distinct pros and cons of each relative to your use case and make those decisions now. The convergence of all of these technologies is unlikely to happen anytime soon, and it's not like any of the high-end laser scanners are going to get any worse. They will also be improving. They will also be finding new ways to provide performance to users too. So for now, I tend to view them distinctly relative to use cases and what your requirements are there.
I was just going to add to that. I think you're much more likely to see Lidar drop immensely in price sooner than you will see, right? So you're much more likely to see Lidar get immensely cheap than, or incredibly cheap than you are to see photogrammetry get incredibly accurate. That's kind of where those trajectories are on. Do we have time for one last question, organizers?
Yes, we can take the final question,
Okay,
and then if we can get everyone's final thoughts on that, would be great.
All right. So our last question is, how do you deal with large data files that you get from laser scanning? Transferring files that are 50 to 100 gigabytes range to clients is very challenging. I agree, it is challenging. We have a number of, yes. That is one obvious answer.
I'm tired of shipping hard drives, so the cloud it is.
And I think 5G, to that point, is hopefully going to help with that as well. The data exchange rates for 5G are insane. So once that really is present, that might make things easier as well. Anybody else?
I always like to say, does it need to be 50 gigs? Does it need to be 100 gigs? Does it have to be structured that contains so much additional information? Does it actually need that? You can either unify point cloud data, you can decimate it down to fit the need. If the specific need, if you're just making a model of it, do you really need a point every half of a millimeter, third of a millimeter, whatever that may be? That's why I look at it. If I can decimate down or unify or make that point cloud more usable, and then save hours of importing, exporting, uploading, downloading, that's what we're trying to accomplish. And then also, you give it to your client. Does your client have the same capabilities that you do? I mean, more than likely, probably not. So you got to make sure, you got to make sure that that you give them something they'll be able to use. So the smaller, I'm a proponent on trying to make the point clouds a little bit smaller, but obviously, when I say small, it's still a huge file. Small is what, 10 gigs?
Yeah, I will say we actually decimate prior to analysis. So people, will often ask, how dense a point cloud do you need? And my answer is usually, you'd be surprised by how little data we can get away with. But yeah, I mean, they are still large files. If they're not 50, they're 5 gigabytes, and that's still a bunch.
I think those are all really good comments. Just be smart about what you're doing with the data in the first place. But we've also recognized that inevitably you have really large files, and getting them from the hardware to the cloud can be really difficult, especially on a remote job site. You know, our approach to that with hardware has been the spot dock, so that while the robot is recharging, it can transmit data over gigabit Ethernet connection, provided you have that port available on site. So I think there are all sorts of different solutions to that, but it's not a problem you can avoid. These 360 video and laser scan files can be quite cumbersome, and if you can't transmit that from the remote site to a shared network location where stakeholders can access it, you're not going to close the loop quickly enough to get value like we've discussed before.
And I will shout out, Brian, to hopefully what's a long-term initiative between our companies around bringing some of that analysis to edge computing. So you can even sidestep the need for uploading to the cloud and getting an analysis back, which, I mean, just that upload, given current 4G capabilities, can take hours occasionally. You know, if we can find a way to get enough processing power on a robot that can process that point cloud, you could have your analysis done in a matter of minutes, which is a really cool vision for the future of reality capture.
Yep.
Yeah, you got to keep your scans focused. There, to reference back to one of the other questions of scanning too much or what to scan. If you're looking for the full sphere, do a low res scan. Then if you're looking for something in particular in that sphere, like if you want to have the complete picture, do the low res scan, let it go. But then if you really want to focus in on something to make sure it's really accurate, a lot of scanners give you the ability to window it out and do a very high density detailed scan of that focus area. Doing that keeps your scans, the scan size down. Decimating, unifying, all that stuff keeps your scan files down. But just again, keeping in mind, what is the use case? Do you need 3 trillion points to know if something's built or not? No.
God, no. No, you do not. All right, thank you so much to our panelists and to our audience. I guess, organizers, how would you like us to wrap this up?
Yeah, so we'd just like to say thank you to our moderator, Raffi, all of our panelists, our sponsor of the session, Avvir, and everyone who has joined us in the audience for this session. All sessions are AIA approved, and you will receive your certificate of attendance within 1 week of today's session. Our next session of the series will be taking place at 3:30 p.m. Eastern Time. This is a panel discussion on solving the construction productivity problem through real-time 3D. Thanks for joining us. Stay safe and see you all online again soon.
Thanks, everybody. I actually want to go to that next one.
Thank you, everyone. From my side,